Okay, hello everyone, and welcome to another video. So today we are going to be looking at trigonometric ratios. And in the last video, I spent quite a bit of time sort of rigorously defining the different sides of our right angled triangle. And we looked at this idea of the hypotenuse, this being the longest side, being relatively constant because this is always the side that opposes my right angle of my triangle. So this will be the longest side. And the other two ones become a little bit problematic because we have an extra two angles here. And the way we define those other sides is from the perspective of the particular angle. So I have this purple dot here, and in relation to this dot, this side is its opposite, and this side is next to it. It's adjacent to it. And this changes if I were, for example, looking from the perspective of this angle. So if you want a more in-depth description, you can watch the previous video as a recap. But today I'm just going to introduce some of the primary trigonometric ratios. And these essentially give us a ratio of sides based on a particular angle in question. So there are three of these, which I'm going to write. One of these we call sine, another cosine, or cos for short, and we have tangent, or tan for short. Now, these all are used to describe the ratio of sides to one particular angle in question. So I'm going to use this angle that I've drawn here. So I'm going to say the sine of my purple dot, the cosine of my purple dot, and the tan of my purple dot. That's just saying, well, these are the ratios of sides in relation to my angle of choice, which is this purple dot. So there is if you've done trig before, like I know it's going to probably be get some like PTSD from memorizing this, but this is an acronym for being able to remember these types of ratios and how they sit. So I'm going to write this here beneath these ones. And we have the acronym being SO, CA, TOA. SOHCAHTOA. This is the only real memorization I'll need you to do. Everything else will hopefully be quite intuitive. So this is an abbreviation. So all of these letters here, are going to stand for words that we've actually been exposed to before. So when we are looking at something in relation to our sine, so the sine of this angle is defined as the ratio between the opposite side to the angle and the hypotenuse. So we can say that the sine of an angle is equal to its opposite over its hypotenuse. So I'm going to write that here, maybe in another color. Equals opposite over the hypotenuse. So some people write this as like, when they write their so, they go like that, so that you can see it's, opposite over hypotenuse. There's more of a ratio there, but you can feel free to write it that way. But I'm going to just have it set out like this, and I'll draw my fractions up here. So My cosine ratio, so the cosine to this angle is defined as the ratio of the adjacent side over the hypotenuse. Adjacent hypotenuse. So let's write that. The hypotenuse. And as you might have guessed, our tan relates the opposite to the adjacent. So the tan of our angle in question is the side opposite to it over the side adjacent to it. So writing that here, opposite over adjacent. Cool. Now, why does this matter? Why have I explicitly defined these things? Well, it allows us to solve certain problems. Now, I'm going to give you one example here of just how we can work through these types of questions. And then we'll actually have an application type of question, which I'll do another video for, which is more of a real world thing where you can see that some things around us we can look at as being made out of right angle triangles, and it can allow us to do quite a few calculations if we're given the right amount of information. So we have one example here. Now I'm going to draw a right angle triangle with a particular unknown. So I will, for example, I'm just going to draw a freehand to save time. So sorry if it's a bit messy, but I'm going to say, all right, well, I have this unknown side x. I know that this side length is 9 centimeters and my angle is 48 degrees. So this is where the video that I did previously will help you be able to identify these, because everyone sees like SOHCAHTOA and all this writing and they get really overwhelmed, right? But by just understanding that some of these, well, most of these sides are just in relation to a particular angle, it will allow you to more steadily go through the question and not get too overwhelmed by it. So we have here an angle in question, and we want to identify first the sides that we're given, as well as the trigonometric ratio that will help us to find our unknown. And I'm going to run you through this really slowly. So in the same way that we did here with my purple dot, I'm going to identify the angle in question. So this one obviously will be my 48 degrees. That is the perspective that I'm looking from. It's the same thing that I said in the last video, where if I was standing here, what sides that are given, what are they in relation to me? Now we'll see that this 9 centimeter, that is opposite my angle, isn't it? So I'm going to actually label that here. And what other side are we given? Well, we're given this x here. And it doesn't matter whether I'm here or here. My x is the length of my hypotenuse, my longest side, my side opposite the right angle. So I'm actually going to write that down here. That's my hypotenuse. So just taking that extra minute to actually label out your sides, especially if you're, in an exam where you're trying to work through questions quickly, it's a really good sense check to kind of make sure you're on the right track, because it's very easy with these types of questions to just rush ahead and then make an error somewhere along the way. So just writing these down already puts us in a really great position. So we have an angle, a known side and an unknown side. And we actually have a trigonometric ratio that links my opposite with my hypotenuse. And that is my sine. So, and you will see on your calculators, this sine, cos, tan, and we'll work through how to use that. But we can say then that the sine of my angle, so the sine kind of from the perspective of my angle 48, is equal to my opposite over my hypotenuse. So I can actually write this down as my 9 centimeters over my x centimeters, my unknown. Now, this is just an equation. We have some unknown and a bunch of other knowns. So we can rearrange this equation to solve for my unknown side, my hypotenuse that I want here. So we can say that 9 centimeters when divided by x is equal to sine of 48. Therefore, that's the same as writing, well, 9 equals to x multiplied by the sine of 48 degrees. Now, we can once again just rearrange this to solve for x. So we can divide both of these sides by sine 48 degrees. And that will get rid of it from my right-hand side. So we have sine of 48 degrees, and this side will get divided by sine of 48 degrees. Now, I'm actually just going to write this again a bit nicer. So we can say that my x, I can represent my unknown side as 9 divided by sine 48 degrees. Now, that is hopefully a nice, relatively simple to follow procedure. And this is how we can solve for our unknown sides. And we'll look at unknown angles later. But you can put this into your calculator if you like. And I'll put it into mine now and give you an answer. And we should get roughly, I'm just going to round this to 1 decimal point. We roughly get 12.1 centimeters. And let's just do a little sense check. Does this length of our hypotenuse roughly check out up here? Well, it kind of does, doesn't it? Because we expect our hypotenuse to be the longest side. And 12.1 centimeters for this is longer than my other known side. So that way it passes kind of like a logic check based on how we've defined the hypotenuse. So in the next video, we'll work through a more real-world example of this type of concept. But the hardest thing sometimes is just taking our time and explicitly identifying the elements of our triangle, the ones we're given. So here, we just identified the angle and said, well, what sides are we given in relation to that angle? And once we identify that we have an opposite and a hypotenuse, we can say, well, hold on a minute. We have a trigonometric ratio that relates these two, and that's our sine. And once we lay out the equation, once we lay it out in this type of form, just from the definition we have up here, we can solve that equation. We can find our unknown side or our unknown angle. So I'll see you in the next video for a more applied example of this type of concept. I'll see you guys there.